So here the circuit is developed with 1 bit comparator with cascade input, which was discussed in the previous lecture, right? Just I saved the circuit and I opened with project load logisim library. So it was opened here and I have taken the main circuit here, right? So this is A greater cascade pin, A equal to B cascade pin, then B greater cascade pin, then A input and B input, then B greater output, A equal to B output, then A greater output, right? So the same I have take two copy so as to develop a 2-bit magnitude comparator using 1-bit magnitude comparator with cascading input concept, right? So as I said earlier, initial setup, select the poke tool. So see everything is equal, right? We are not getting the equivalent pin output on the final stage raised to 1. It was still 0. So this is the initial setup. So cascade pin A equal to B should be connected to the VCC, and cascade pin A greater than B, A less than B should be connected to ground. Then from one stage to next stage, so the output of B greater should be connected to the cascade pin of B greater of the second stage. Likewise, A equal to B will be connected to the output of, sorry, input of A equal to B cascading input. Then A greater will be connected to the cascade input of A greater in the second stage, right? So everything is equal and initial setup was done. Everything is equal. We are getting equivalent pin output as 1, remaining 2 or 0. Then now LSB is higher. In LSB A is higher, but MSB A is equal and B is equal, right? So see the output A is greater. Likewise, here in LSB B is greater. See here we have getting B is greater, right? In MSB A is greater, right? When compared to A naught and B naught, A naught became 1, so A is greater. So we are getting A is equal to greater pin to 1. But in MSB, suppose the case whether B is greater. So even though in LSB A is greater, but in MSB B is greater, the B greater pin should be raised. Likewise, the same condition in LSB, we have B is greater, but in MSB we have A is greater, then we will get the A greater output, right? So everything is equal in all the stages, then we are getting the A equivalent B. So saving this circuit, again we can able to consider this will be a 2-bit magnitude comparator, right? Saving this circuit, again we can able to build a 4-bit magnitude comparator. So that also done, right? So look out here, we have 4 input A0, A1, A2, A3 is compared with B0, B1, B2, B3. So this is the circuit. It was saved with 4 input stage. So it is a 2-bit magnitude comparator and a 2-bit magnitude comparator. Right. Again, we have to make with the initial setup. Equivalent cascade input should be 1. Then everything is equal, getting the output as equal. Then if you are varying the stages, so A greater equal, A greater equal, A greater equal A greater equal. Then again varying the stage B greater equal B greater equal, then B greater again equal, then B greater again, then equal. So in all the part of your LSBs are equal, but in the MSB we have one bit as 1 in B, then B is greater. So likewise we can able to build n stage of comparator also. So we have specifically a ready-made IC with a 4-bit comparator. What we are seeing here in Logisim response, the same IC is ready-madely available. The IC number is 7485. It's a 4-bit magnitude comparator. So let's see the demo of 4-bit magnitude comparator in lab kit. Thank you.